Welcome! In this video, we'll continue our discussion of chemical bonding, and this time we're going to talk about ionic compounds and their physical properties. So once we form an ionic compound, what kind of stuff does it do? So ions form a crystal lattice, which turns out to be a neutral compound, so there's no net charge, that is composed of ions in a special 3D arrangement. So this 3D arrangement is going to maximize the electrical attractions among our positive and negative ions. Remember, our positive and negative ions will attract. So if we take a look at this example, this is sodium chloride. We have alternating particles here. So we'll have sodium chloride, sodium chlorine, sodium fluorine, right? So we have alternating positive and negative charges in 3D space, right? So we've got positive charges all around surrounding our negative ions, and these will pack in really tightly. Ionic compounds, because they have that really tight packing and those really strong interactions, they have high melting points. It takes a lot of temperature, a lot of heat to get them to melt, which means our ionic bonds are very strong. And in fact, electrostatic forces are 10 to the 25th as strong as gravitational forces. So if you think about the force holding you on the Earth, it's the force in between ionic bonds is going to be much greater than that. These compounds tend to be brittle, which means they'll shatter when you drop them or strike them with a hammer or other blunt object. So they'll turn into very small objects after being met with physical force. Also, our ionic compounds, some of them are able to dissolve in water. So when we put something like salt in water, it does dissolve, and each of our individual ions will be surrounded by water molecules. And then they come apart and it looks like they're gone, but the ions are just in solution. They break off of the solid and float freely in our water solution, which is also called an aqueous solution. When ionic solids are dissolved in water, they're really good conductors of electricity. And only when they're dissolved in water into their component ions or melted can these substances conduct electricity very well. These electrons are able to move from ion to ion when we put electricity through these solutions. And when we have ions in solution that conduct electricity, they're called electrolytes. So that's a word that we'll probably use quite a bit. However, when we have our ionic solids in the solid crystal lattice form, they are not good conductors. Because when they're in this solid crystal structure state, the ions are in fixed positions and electrons from electricity cannot flow or move through them. Okay. So that's it for ionic compound properties. Remember, ionic compounds are made of ions that are positively and negatively charged. In the solid form, they form a lattice with alternating positive and negative charges. These solids that are formed are very brittle. The bonds are very, very strong and require high temperatures to melt them. Many ionic compounds can dissolve in water, where they dissociate into their individual ions. And when they're in water, they can conduct electricity very well as electrolytes. So it's important to keep these properties in mind, because when we have other types of compounds, we can use them to compare. Okay, great job today. See you next time.